Okay, so in this lecture, we will be talking about approximate inference. And as I told you previously that under this approximate inference, we will be mainly talking about the sampling. There are various types of sampling that we will be discussing in this lecture, also in the upcoming lecture. Okay, so let's get started. Yeah. So if you see here, as I told you just now, so when we talk about Bayesian inference in Bayesian networks, so we have two types of inferences. One is exact inference and the other one is approximate inference. When exact inference is not feasible or computationally it is, very expensive, then we go for approximate inference, right? So if you remember this slide, I included this slide also in the previous lecture, and basically it is talking about the properties of variable elimination algorithm, right? So now there are some disadvantages of variable elimination algorithm. One of the disadvantages, it can have, if you are choosing a bad elimination order, then it may give you huge factors, right? Or if the Bayesian network is very complex, then also it will be computationally expensive, and it will be complex to compute the exact inference from that particular network. So that is the reason we have to go for other methods. We have to look out for other methods, and now we are going to talk about the approximate inference. When, as simple as that, when exact inference is infeasible or computationally expensive, then we go for exact inference. And in this we talk about mainly the sampling part. So we will be discussing in the Bayesian network how we can perform this sampling. Okay, so, and for today's class, mainly all the slides, I would say almost all the slides are from Berkeley University. Okay, so yeah, that's it. I haven't mentioned anywhere, but yeah, I wanted to just let you know this. Okay. Fine. So if you remember this Bayesian net representation, we know that it is a we have already covered. It is a directed acyclic graph, right? One node per random variable, it is there. We know what is conditional probability, and we also know that how we can write the joint distribution, right? Using this Bayesian network. So we know all these things. This slide is just a quick recap of what we know already related to Bayesian network, right? So nothing different here. So again, for exact inference, we talked about variable elimination. So interleave joining and marginalizing was there, right? Again, the same things are mentioned over here also, that a huge number of factors can be possible. D for k entries computed for a factor over k variables with domain size d. A domain size means what? That means how many possible values a variable can take. So these many entries you have to compute, right? In case of variable elimination. And order of elimination of hidden variables can affect the size of factors generated. And worst case, a running time exponential in the size of the Bayesian network, right? So if you have this kind of Bayesian network, then you can clearly see that how it will be really complex to compute the exact inference or to make exact inference out of it, right? So that is the reason why we don't use it in case of complex Bayesian networks. And finally, we are going to start today's topic, that is approximate inference. And under that, we will be talking about sampling. Clear so far? That whatever we have discussed so far, that was just a quick recap of what we have covered and what we already know, right? Now, what is sampling and why we do sampling? Any idea what we do whenever we say sampling? What does that mean? Anyone? You might have heard this term sampling in at a lot of places, I guess. Can I say sampling means, just picking out the samples from the entire distribution? Yeah, exactly. Picking one element from set of elements. That is absolutely correct. Very good, Gurdeep. So this is get idea of population. Yes, that is also correct. We talked about in big data when we talk about population. So we pick a sample for it, and from that sample we make an inference for the entire population also. So that is absolutely correct, Chandana. Very good. So yeah, so why we do sampling? So basically it is we get the samples from a distribution, and Distribution you don't know. When you don't have the much idea about the entire distribution, then we get the samples from it so that we can learn the pattern, we can make some inference from it, right? So here also it is mentioned why we are doing sampling. So getting a sample is faster computing the right answer, faster than computing the right answer, and that is absolutely correct. When we are making the inference, when we are making the approximate inference by getting a sample, that is faster as compared to getting the exact answer. For example, in case of variable elimination we have seen, right? So if you compare these two approaches, obviously you will be getting the approximate answer, not the exact answer, but by that approximate answer you can make some inference of the entire distribution. Yes or no? So this is why we do sampling. Clear? Now sampling is a lot like a repeated simulation, like predicting the weather, basketball games, etc., etc. So there are a lot of examples, but what is the basic idea behind this sampling? So what we do actually, so you can see here we draw n samples from a sampling distribution S. So if we have the entire distribution that is S, we draw out some samples, let's say n, and then we compute the approximate posterior probability out of those samples. Let's say you have a distribution, let's say you have a distribution or collection of, let's say, 100 maybe things or any stuff, right? Now out, or let's say 1 lakh stuff, right? Now it will be for you it will be impossible to to perform or to get an idea of the entire distribution. So you just pick some elements, as Gurudeep said, that you can pick some elements from the entire set of elements, right? And then for those set of elements, or you can say samples, you will be computing the posterior probability. So approximate posterior probability will be computed, and that posterior probability will converge, or you can show this convergence to the true probability. When I say true probability, that is probability for the entire distribution, right? So you compute an approximate posterior probability and show this how it converges to the true probability. So this is the basic idea of how we do sampling, and this basic idea is applicable wherever we perform sampling. Okay, fine. Now let's understand this through one example. So sampling from given distribution. So what is basically, let's say you have you want to get a sample U from a uniform distribution, and that is ranging from uniform distribution, you know, that ranges from 0 to 1, right? So here it is starting from 0 and open parenthesis, I mean this parenthesis means 1 is not included. So for example, random in Python. So if you use this function in Python language random, it always generates a value between 0 and 1, including 0, right? So what is the step 2? So what you do here, so basically you convert this sample U, whatever value, that sample U means whatever value you are going to get, you are going to convert that into an outcome for the given distribution by having each outcome associated with the subinterval of 0, 1, with subinterval size equal to the probability of the outcome. If you haven't understood, no worries. With this example, it will be crystal clear to you. So let's consider this example carefully. Let's understand this. So let's say you have some color. C represents the random variable for color. So it may be red, it may be green, it may be blue, right? And these are the probabilities for these colors. So if you are picking up a box of these colors, so what is the probability of color being red? That is 0.6, for green 0.1, for blue it is 0.3. Now what we are doing is we are basically trying, let's say if you use this random function, right, and it will return some value between 0 and 1. Now how this value can be mapped to these probabilities or to this particular distribution, so that you can associate that value, with the you can say with the outcome of whatever event that you are doing, or whatever event you are considering. So let's understand this way. So what we are doing is, if I'm trying to have a distribution of this probability, so the probability of red is 0.6. So what we have done is we have distributed this from 0 to 0.6, it is red, right? And then 0.1, so from 0.6 to 0.7, including 0.6, that is for green, and it is 0.3, so 0.7 to 0.1. So if you take the difference of these two values, it will be same as the probability of uh, you know uh, uh, the color being red, green, or blue. So here it is 0.3, so 1 minus 0.7 will be 0.3 itself. So this is how we are distributing these probabilities between using this uniform distribution between 0 and 1. Okay, so this is what we have done. Now if you just use this function random, and let's say it returns, just for example, it returns 0.83. So we can say that this sample u we can convert this into the outcome, right, using this distribution. Now this is the distribution that we are going to use, and this u, it is 0.83, so we can say that it lies between this range, 0.7 to 0.1, I mean 0.7 to 1. So definitely our sample is blue here. So this is just an example of how we do sampling. So far we haven't discussed the types of sampling we have in this approximate inference. This is just the example of sampling, right? So example, after sampling 8 times, you may be getting, these many times red, these many times blue, these many times green, based on the probability, nothing else. Is it clear to all of you? It is 5 by 8, it is 2 by 8, it is 1 by 8, something like that. Is this clear? Understood the idea of sampling? That is important, because understanding the idea behind sampling, it is very important, so that you can understand the other topics also, I mean the upcoming topics also, right? Okay, so now in the Bayesian network we have these four types of sampling. One is prior sampling, then we have rejection sampling, then we have likelihood weighting, and the last one we have is Gibbs sampling. Okay, in this lecture we will be talking about these three, right? Once you understand these three, then this Gibbs sampling, and one more we have, that is Monte Carlo sampling. So that will be covered in the next lecture. Okay, so let's talk about these types of sampling one by one. So first of all, we will be talking about prior sampling. You know what is prior probability, right, everyone? It is similar to that only. The idea, the point is just we are doing the sampling here, but the basic idea is same to how we calculate the prior probability, or how we talk about the prior probability. But prior probability means there is no evidence, there is no condition already given to you, yes or no? I hope you remember this. So that is what the idea behind this prior sampling. So let's understand this through one example. So this is a Bayesian network given to you, right? And when I say Bayesian network, that means you have a graphical model. So graphical model is given to you. And apart from that, the CPTs are given to you, which is conditional probability tables. So this entire thing, we can call it as Bayesian network, right? So now, as you can see, this is all are your part of CPTs, and this is a graphical model. Now, let's say these samples are given to you. There are, let's say, many more samples, but as of now, you can see on this slide that these two samples are given to you, right? Now, if I simply ask you, let's say, where do we have that example? Yeah, just a minute. Okay. If I simply ask you, what is the probability of W? What is the probability of W based on these samples? Understand this thing. Before this class, or before this slide, we haven't talked about, finding the probability when we have certain set of samples, right? Like previously in the whatever lectures we have covered in the probability, we haven't talked about in terms of samples or in terms of sampling, right? But we generally compute the probability, but which is nothing but the exact probability. Now here, samples are given to us. Based on these samples, like here you can see in this first sample, it is plus C representing cloudy. So all four, these are the four random variables: cloudy, sprinkler, rain, wet grass. And all these random variables are Boolean random variables. That means they are having two values, either cloudy or not cloudy. sprinkler or not sprinkler, like this. So true, false, like this. Okay. So in this first sample, if you carefully observe, what do we have in this first sample? It is saying it is cloudy, it is not sprinkling, it is raining, and the grass is wet, right? So this is what this sample is indicating. Now, based on the samples given to you, if someone asks you what is the probability of W, can you tell me how you can calculate based on the samples, probability of W? So let me make you understand. Let me make you understand how we can do it. So when I say probability of W, you know that either W can be positive, either it can be plus W or it can be minus W, right? It can take two values. Yes, variable elimination you can apply. But now here we are talking about in terms of sampling. So carefully understand this. So when I say probability of W, so either it can take positive value or it can take negative value. That means either the grass is wet or the grass is not wet, right? So now if I ask you how many, if I ask you the count of plus W out of these two samples, what is the count of plus W? Can you tell me? So your answer will be 2. Can I say 2? Yes, because you can see in this sample also it is plus W, in this sample also it is plus W. So I can say the count is 2. Okay. What about the count of minus W? It is going to be 0. It is going to be 0, right? But now, is this the probability? No. Then we have to normalize it. Once we normalize it, because we have to get the value of PW, so we have to normalize it, right? So if I normalize it, what I will be getting? So can I say that for this plus W, it is going to be exactly 2 by the total number of, can I say total number of samples? Yes, it is going to be 2 by 2, that is 1. And if I ask you probability of minus W, so it is going to be what? It is going to be 0 by 2, that is 0. Is this point clear to all of you? Very simple example, just to give you an idea of how we are considering the samples. Is this clear? Any doubt, anyone? Take your time. I'm giving you 10 to 15 seconds. Take your time. If you have any doubt, do let me know. If it is all clear so far, just give me thumbs up in the reactions so that we can proceed. 2 by 8, Manjunath, we can consider, see, understand this thing. If the samples are given to you, let's say there can be many possible samples, right? Okay, if I ask you a general question to all of you, how many samples are possible? Total samples are possible. Wait. How many total samples are possible? Like you have, see, understand this thing. You have 4 random variables here, right? Cloudy, sprinkler, rainy, and wet grass, right? And all are binary or Boolean random variables. So can I say 2 into 2 into 2 into 2? That means total 16 are possible. Do you agree or not? Correct. Total 16 are possible. But the point here is, out of total possible samples, whatever samples already given to you, you have to consider only those. So we are considering the bunch of samples that is given to you from this Bayesian network. Are you getting this point now? We are not considering all the possibilities of samples. Because why I'm saying so? If understand, this is very, I would say common sense question. I mean, common sense statement that if I'm considering all the samples, ultimately I will be talking about the entire distribution. Do you agree? If I'm considering all the possible samples, that means what? That means I'm talking about the entire distribution. But whenever we perform, we consider the number of samples that we have taken. We don't talk about the entire distribution, because we are trying to make an inference out of those bunch of samples. So whatever inference we make out of those bunch of samples, we basically reflect it to the entire distribution. Making sense? Clear, Gurudeep and others? Okay, good. So here in this question, like in this example, we have just 2 samples. Later on, you will see we have 5 to 6 samples. Then we will be considering those many, right? So I hope this is clear to all of you. So this is the algorithm for this prior sampling. The same thing we are doing, like it will be running for n nodes, that means n random variables. So sample x from p of xi if there is independency, so like this, and it is going to return the the distribution that we have, the complete distribution, right? So this is just an algorithm. Algorithm is not important for you, so you don't have to worry about it at all. Just I have mentioned in the slide so that it will be like a complete lecture. 2 sample means 1 row, 2 row, right? Yeah, here there are 2 samples, right? This is 1 sample, this is another sample. Okay, total samples are given, but here if someone asks you how many samples are there, so 2 samples are there. Fine. Now let's see this example. This example will give you more clarity. So carefully see this. The same Bayesian network we are considering: cloudy, sprinkler, rainy, and wet grass. Now we will get a bunch of samples from the Bayesian network. Let's say these are the samples given to you, or you can say bunch of samples given to you. Now again the same thing. If I want to know what is P of W, so how we can calculate? First we are going to count the number of positive W and negative W. That means the grass is wet or grass is not wet. So out of all total 5 samples, you can clearly see that 1, 2, 3, and 4. These 4 are having the value plus W, and only one is having a negative W. So you can say we have the counts, right? Out of these samples only we are considering. So we have the counts, and now to get the probability, we have to normalize it, right? So you can say normalize to get the probability, and you know how to normalize. Just now we have done. It will be a 4 divided by total, that is 5, and here it will be 1 divided by 5. So that will give you this probability, which is for positive W it is 0.8, and obviously for the remaining one it is going to be 1 minus 0.8, that is nothing but 0.2. Is this clear? This prior sampling is clear, very simple, and it is very rare that they are going to ask question from this, because this is very simple, quite simple, right? But is it clear what is prior sampling? You know what is the meaning of prior? That means there is no condition, there is no evidence already given to you. Fine. So this prior sampling, this will get closer to the true distribution with more samples. If we are considering more and more samples, definitely we will be moving towards, or you can say we will be moving closer to the true distribution that we have for the entire, if you consider entire distribution, so it will be closer to that if we add more and more samples, right? And can estimate anything else too, so that is fine. But now the question is, now carefully understand, what about these questions? Carefully see this. Probability of C given the grass is wet, or probability of C given it is rainy and the grass is wet, or the probability of C given it is not raining and the grass is not wet. What about these type of questions? What about these type of probabilities? Then can I say that for these type of questions you cannot use prior sampling? Do you agree or not? Yes or no? Because now you have the conditions, right? Now already some evidence, some condition is given to you, correct? So when some condition is given to you, then you cannot use prior sampling. But this prior sampling is quite fast, can use fewer samples if time is less. But what is the drawback? The drawback is it cannot answer obviously these type of questions where some evidence is given, obviously. And what you are doing, basically you are doing approximation. You are doing approximation, right? Is this clear? Any doubt, anyone? So that is the reason now we are proceeding towards the next sampling, which is rejection sampling. Yes, Manjunath, again. See, the point is simple. When you have to answer these type of questions, when some evidence is already given to you, then you cannot use prior sampling, right? Prior sampling means there is no condition, there is no evidence already given to you. You are simply finding probability of W, right? Similarly, probability of C, probability of S, probability of R, you can find it out. But if you have these type of questions to answer, then you cannot use prior sampling. Then you have to go to the next type of sampling, which is rejection sampling. Clear? Okay. But it is fast. Yeah, you can say for fewer examples, if you have less time, then definitely just for making an inference, you can use prior sampling. But there are always a drawbacks, right? There are drawbacks. So now we are going to talk about the rejection sampling. And in case of rejection sampling, ultimately you are going to use what? Conditional. Conditions will be there, evidence will be there. So let's understand it step by step. So let's say we want to calculate P of C. It is quite simple, right? So no point keeping all samples around. So you can consider all the samples. It is talking about what? It is talking about the prior sampling, because P of C means what? P of C, P of W, whatever we say. You can consider all the samples. Do you agree? Let's say they are providing you sample one by one. Then what is going to happen? Let's say this first sample comes to you. First of all, you don't have all the samples as of now. Let's say this first sample is given to you. Now, if this first sample is given to you, what will be the probability of C? Can you answer this? Anyone? If I simply ask you this question. Probability of plus C, basically, not just C, probability of plus C, sorry. Can I say it is simply 1.0, or you can simply say 1? Yes or no? Any doubt, anyone in this? If you have just one sample, can I say probability of plus C is 1? Yes, because it is plus C here and you just have one sample. So 1 by 1, it is 1 only. Okay, let's say now the next sample is also given to you. Can you answer what is the probability of plus C now? The answer is again it is 1. Again it is 1, right? Because now you have two samples and in both the samples it is plus C. So 2 by 2, it will give you what? 1 only. Let's say the next sample comes. What is the probability of plus C now? Plus C, plus C. So now the probability of plus C will be 2 by 3. Is this clear? Are you getting it or not? So the same thing it is mentioned over here, that no points keeping all samples around. So basically, whatever samples it is coming, you can consider them and just tally counts of C as we go. Whenever you are just proceeding, as you get more and more samples, you just have to keep the track of the count on C. And this is how you are calculating the probability of plus C. Is this clear so far? Similarly, you can do it for this one also, as more and more samples are getting added. So this is fine. This is fine. This is easily you can calculate. But the problem, when there will be a problem? Let's say we want to calculate this now. Probability of C given it is sprinkling. Then now you have the problem. But now what you have to do, if let's say if I want to calculate this, what should I do now? Can I say if in order to calculate this, out of all these samples, I should consider, like, just think about it, logically. What should I do? If this is given to you plus S, and this is quite related to the basic probability, conditional probability that you already know. If this is given to you, it is sprinkling, and these 5 samples are given to you. Now what you will do? Obviously, you will consider only those samples where it is sprinkling. Filter out. Yes, exactly. You will just simply filter out. Yes or no? Correct. And out of these, so you can see in the first one it is minus S. So you are not going to consider it. Here also, here also. So can I say just these 2 samples you have filtered it out? Right. And now out of these 2 samples, you will be finding out the probability of C given plus S. Do you agree? Yes or no? Is this clear now so far? And this thing is nothing but rejection sampling. This type of sampling is rejection sampling. So what it says, carefully see, the same thing, tally C outcomes, but ignore or reject samples which don't have s is equal to plus s. So you have to ignore those samples. You have to ignore those samples, right? And this is called rejection sampling. It is also consistent for conditional probabilities. Is this clear? Why this was not possible in prior sampling? We could use filters. See, but again, see, they have classified these samplings into these types. When I say prior sampling, that means there is no condition already given to you. Are you getting this? Once you apply the condition, then it is no more prior sampling. It is in the definition itself. Then it is no more the prior sampling. Then it becomes the rejection sampling because you are rejecting already some samples. So it is just a classification. Is this clear, Gurdeep? Okay. Any other doubt? Anyone else? Anupam, Abhas, Chandana, Manjunath, all clear, crystal clear so far? Shall we proceed now? Which value? Yeah, now it depends now. Okay. Now it depends what you want to calculate. Let's say if I ask you, can you answer this? Anyone? Using this rejection sampling, can you answer this? 1/2, as simple as that. Is this clear? Because this is having plus s, this is having plus s. Any doubt, anyone? Crystal clear? Okay. So this is rejection sampling, right? And this is the algorithm of the rejection sampling. Fine. Now we have the next type of sampling, which is likelihood weighting, So what it says, let's try to understand. Like, in order to understand this, we should first know, right, what are the problems with rejection sampling? Why do we need this even likelihood weighting? If we can answer all the questions using rejection sampling, then why do we need this? So let's understand the problems in rejection sampling. So what are the problems in the rejection sampling? See, you can have these type of problems. What if evidence is unlikely? If whatever is given to you, whatever evidences you have, that is unlikely, then it may be possible that you will be rejecting a lot of samples. Yes or no? Correct. Let's say from this example only, let's say if I ask you maybe minus w, that means the grass is not wet. So in that scenario, can I say that you will be rejecting all the remaining 4 samples, right? So if the evidence is unlikely, in that case, you will be rejecting a lot of samples. And when you reject a lot of samples, then evidence will not be exploited, right? And when you, let's say, you can consider this example also. Consider probability of shape given blue. Let's say you want to find out this. Now here the evidence is that the color is blue. It is already given to you. Now you have to find the probability of shape given the color is blue. So if, let's say, these are the samples given to you, understand carefully, if these are the samples given to you, can I say just you are left with this one only if you are applying the rejection sampling? Rest all the samples you are simply discarding or rejecting, right? So you will not be able to exploit this evidence. You will not be able to use this evidence properly, right? And so what is the idea, or what is the solution for it? So the idea they proposed is we can fix evidence variables. So when I say fixing the evidence variable, that means I'm fixing this blue. Okay, I'm fixing this blue and I'm going to sample the rest. That means based on the evidence variable, whatever evidence variable I have, let's say the color is blue, I'm going to fix it and based on that I'm going to find out the samples from the rest. Getting the point? Okay, so once I do that, what will happen? So you know the problem, you understood, right? That sample distribution is not consistent. If you carefully see, sample distribution is not consistent. This is a problem. Then what is the solution? The solution is simple: weight by probability of evidence given parents. Okay, so far what we are doing here, if you carefully see this, now we are going to have this kind of sample where we are fixing the color, because we are only interested in where the color is blue. So what we are doing, based on the evidence, we are fixing that evidence variable, and then we are sampling out the rest. So now if you carefully observe, we have all those samples where the color is already blue and the shape is maybe pyramid, sphere, cube, and sphere. Are you getting this point? Yes. So we are fixing the evidence. Now the color we have fixed that it is blue. So once we are fixing the color, that means now we are not going to consider any other color. And then based on that, after fixing it, then we are sampling the rest. So now we have this kind of bunch of samples, you can say. Clear? So once we are going to solve some question, you will understand how we are using it. Okay. So just wait for some time. Okay. So ultimately, what we are actually doing is, previously it was what? Previously it was, you can say, if let's say this is the network given to you, so you can say it was shape given color. Yes or no? It was shape given color, or C can be like, here it is blue, right? So it would be better if you write blue here. Fine. This is what you were trying to find out. But now once we are fixing this evidence variable, now what we are doing is we are trying to find out this. Is this clear? Evidence given query, right? I hope you know this. Maybe I have covered this before. We write this, right? Query given evidence. So we have some query and we have already some evidence given to us, right? So previously we were doing this, but now what we are doing is we have fixed the evidence, and now based on the query, so you can say query is given, now we are finding the probability of this evidence. So this is actually this weight by probability. This is nothing but weight by probability of evidence given parents. Is this clear? Making some sense, if not entirely? With example, you will be understanding more and more once we solve one or two questions. And also I have included one question which was asked in mock exam. So the IITs, the GATE authority, basically the organizing authority, they release one mock paper right before the exam, before I think 1 or 2 months or maybe 3 months before the exam. So in GATE 2024, when they introduced GATE DA exam, they released one mock paper. I hope you might have solved it. Some of you might have solved it before as well. So that mock paper, there is one question based on this likelihood weighting. So I have included that question in these slides, and we will be solving that question at the end. Okay, so that you can get the entire clarity of what kind of question we can expect from this particular topic. Fine. And you will be understanding how we are using this likelihood weighting. But before that, you need to understand the concept that what we are trying to do. So basically we are using this weight by probability of evidence given parents. So that means probability of blue given shape here. Okay, so we can also write like this, that if I talk about this first one, so there will be some weight, let's say weight 1, and how we are trying to find out, you can say, let me write it on the next slide. So if let's say it is pyramid comma blue. So I can say that we are going to find this weight by probability, and it is nothing but probability of blue given pyramid. Similarly, if I have something like this, maybe sphere blue, so again we are going to find some other weight, let's say W2 for this blue given sphere. Is this clear? This is nothing but likelihood weighting. Any doubt, anyone? If you have any doubt, please ask. Because now we are going to solve one question after that. Clear? Understood? Everyone? Shall we proceed now? Okay, good. Let's see this particular question based on likelihood weighting. So again, the same thing is given, the Bayesian network is given to you, right? And this particular sample, only one sample is given to you, let's say. Fine. Now, what is the evidence? Let's say the evidence is plus S, that is, it is sprinkler. So how we are writing this evidence based on this Bayesian network, also you can understand that they have marked this one. That means it is sprinkler and it is wet grass. Just a representation, nothing else. Okay. So let's say this is the evidence given to you. Fine. Now, if I ask you a simple thing, can you write the joint probability distribution for this one? Cloud, sprinkler, rainy, and wet grass. What is the joint probability distribution? So you will simply say that it is going to be probability of C multiply probability of sprinkler given cloudy multiply probability of rain given cloudy multiply probability of wet grass given sprinkler and rainy. Yes or no? Agree? This is the joint probability distribution. Yes. Now if I have to find, so what we are trying to find now, for this particular sample, point, basically we can say sample point, when we are talking about one particular you can say this, basically we have bunch of sample, or we can say samples, but a particular sample we call it as sample point. This is the you can say terminology, nothing else. So for this one, we are trying to find, let's say W. That means the weight by probability. Okay. We are trying to find the weight by probability for this particular sample point. Okay. So how we can do that? So can I say, so our sample is, let me just write it. Our sample is plus cloudy. What it is? Yeah. It is plus cloudy, plus sprinkler, plus rainy, and I think plus wet grass, right? Yeah. So this is your sample point. This is your sample point. Fine. Okay. Now, based on the sample point, this joint probability distribution, how I can write? Probability of plus C. So, yeah, one more thing here. You can simply write probability of C here. Ultimately, I don't want to confuse you. So what we can do is simply understand this thing. I will talk about this part in some time. So probability of S given C. See, what is our evidence? Evidence is plus S and plus W. This is our evidence. So we only have to focus on our evidence. So can I say this is part of our, basically this is our weight by probability evidence given parent. So I can write like this, probability of plus S given plus C. Yes or no? I'm talking about just this part. Because this is our evidence. Just now I told you, in case of example of shape and blue, what we are trying to find out, probability of blue given shape, particular shape, right? Or you can say given parent. So now we can write like this, because we are talking about this particular sample point. So it is plus S and plus C. Correct. What about this one? Here, do we have our evidence involved in this one? No, we don't have our evidence involved in this one. Similarly, we don't have our evidence involved in this one. So for those, the initial weight will be 1. The initial weight will be 1. Are you getting this point? The initial weight where our evidence is not involved, we consider the weight as 1. In the algorithm, it is there. I will show you. Okay, fine. Now, what about this one? Yeah, here we have this evidence involved here. So I can simply write plus W given plus S plus R based on our sample point, plus S plus R based on our sample point. Is this clear so far? I'm giving you 30 seconds. Carefully look at it. If you have any doubt, please ask. Everyone. All clear? Okay. So now using the CPT, we can find these values. Yes. So probability of plus S given plus C. So plus S given plus C, plus S given plus C. Can I say this is the value 0.1? Correct? Plus S given plus C? Yes. And what about probability of, let me just write 0.1. And what about this probability of plus W given plus S and plus R? Given plus S and plus R, probability of plus W, that is 0.99. Correct? So it is 0.99. So what is the probability? This is going to be 0.099. Is this point clear? This is what they have calculated here as well. So they have written it directly. I explained you why we are writing it. Is this clear to all of you? So for this particular sample, this is how we are going to compute. Now, let me give you one question and you have to answer. You have to find the probability for that particular, you have to find the weight for that. Okay. So let's say it is minus C plus S minus R plus W. Start doing this. Tell me, what will be the value of weight for this particular sample point? Then I will be solving this. Yes, that is absolutely correct, Manjunath. Everyone getting the same answer or something different? So let's see how to do this one. So it is very simple. Let me just add one slide here. Let's say this is the sample point plus S minus R plus W. Right, this is the sample point. So we know the joint distribution can be written as, that this probability of C will be 1 only. We have to consider 1 only, right? Because there is no evidence involved in it. And in other words, you can say the initial weight is 1. Initial weight is 1. So for this, it is 1. For this, it is, probability of sprinkling given, not cloudy, multiply. This is I'm writing using this joint distribution only. Probability of rainy given cloudy, that is also 1 because I don't have any evidence involved in it. And then we have probability of plus W given, what do we have? S and R, right? So it is plus S minus R. Fine. So what are the values here? So you will simply say plus S minus C, you can find it out. Plus S minus C, that is nothing but 0.5. That is nothing but 0.5. So this is 0.5 plus W given plus S minus R plus S minus R plus W, that is 0.9. That is 0.9. So final answer is nothing but, you can say the weight for this one is 0.45. Is it clear? Any doubt, anyone? If you have any doubt, please ask. Okay, shall we proceed now? Fine. So we can see this is the algorithm. This is the algorithm for this likelihood weighting. And carefully observe here, initial weight for every, you can say initial weight for every probability that you are finding, it is 1. And then if xi is an evidence variable, if xi is an evidence variable, then only you are changing the probability for that. Are you getting it? If it is not, then simply you just simply sample out xi from this one. Clear? Okay, so this is the reason why we are keeping it as 1. Fine. Again, this slide you can just give it a read, but again, not very important for your exam point of view. You here you need to understand how this the sampling method is working. That is more important. The same thing, whatever I've explained to you, the same thing is mentioned over here. But again, these are some fancy explanations, or these are some fancy way to represent what we have done. But the point is the same. They are also talking about the same thing, nothing else. Clear? So just to keep things simple, let's proceed. So likelihood weighting. Likelihood weighting is good. We have taken evidence into account as we generate the sample. Are you getting this? To generate the sample, we are taking evidence into account first. So example, W dash. So this is what we have, right? Let me just write it here. It was cloudy. Carefully see this sprinkling. It was rainy here, and it was wet grass here, right? This was the Bayesian network, the graph. So carefully see this. Example WS values. So W's value basically will get picked based on the evidence of S and R. So what value you are going to pick for W, that will depend on the values of S and R, because these are the evidences. More of our samples will reflect the state of the world suggested by the evidence. So that is the reason why likelihood weighting is good. But there is some problem, or there is some, you can say, little disadvantage in likelihood weighting as well. And what is that? Likelihood weighting does not solve all our problems. Why? Because evidence influences the choice of downstream variables. Whatever evidence you are considering, for our example, we are considering the evidence as S. Let's say we are considering the evidence as S. So what evidence? That, let's say it is plus S, right? So this plus S, let's say that this evidence that we are considering, can I say it will influence the value of W but not the value of C? Yes or no? Correct. Whatever evidence you are considering, plus S plus R, or just let's say plus S, just for understanding purpose, can I say that this evidence will influence the value of W but not C? Correct, based on the network, how we have this network here, right? So the same thing is mentioned over here in this particular line, that evidence influences the choice of downstream. What choices you are going to make for W will depend on the S, will depend on the evidence, but not upstream ones. For example, C isn't more likely to get a value matching the evidence. I hope this point is clear to all of you. That means ultimately what we are saying, that we would like to consider evidence when we sample every variable. If I'm sampling every variable, ideally I should consider evidence for every variable. Yes or no? right? But it is influencing the downstream variables, not the upstream variables. So for this purpose, we have another type of sampling, which is nothing but the Gibbs sampling, which we are going to cover in the next lecture. Is this clear? The flow is clear. We started from prior sampling, then rejection sampling, because we have questions like conditional evidences given to you, and then we proceed. We saw the problem in rejection sampling also. Then we proceed to likelihood weighting. Now we are seeing some more problems because it is not solving all our problems. So we have seen that another approach, we are going towards the another approach, which is nothing but the Gibbs sampling. Is this clear? Any doubt, anyone? If you have any doubt, please ask. Crystal clear? Okay. So now we are going to solve this question that was there in the mock paper of GATE 2024. No, very, very rare chance. I'm saying, let's say 1% chance. Let's give some probability to this also. So let's say 1% chance is there that they may ask 1 mark question, basic 1 mark question, maybe from rejection sampling. Okay. But it is highly likely that they will ask question from likelihood. They may ask question from likelihood weighting this year, because in GATE 2024 there was no question from this topic. So it is high chance that they may ask question from this likelihood weighting. It is possible. Okay, so keep this thing in mind, or you can just write it somewhere so that you can just keep in your mind that you just have to revise. You just have to revise how to solve these type of questions. You understood the concept clearly. Now how to solve these questions, you already know, but I'm going to solve this question again for you so that you get entire clarity, because this question was there in the mock exam of GATE 2024. And in GATE 2024, they haven't asked question from this. So definitely there are high chances this time. Okay, so let's say this question, let's read this question now. Consider the Bayes net or Bayesian network, you can say, containing 4 Boolean variables A, B, C, and D with the following convention. So if it simply says A, that means true, or A is equal to A is equal to false, you can write like this, not of A, correct? And it is applicable for other variables also, like B and C and D. Fine. The conditional probability tables, CPTs, are given to you in, for the nodes in the network are also indicated in the figure. As you can see, the following samples were generated through likelihood weighting. Clear? These samples. Which samples? These samples. S1, S2, S3, S4. So there are 4 samples given to you already. And they are saying that these samples are generated through likelihood weighting. What the question says? The question simply says, estimate the likelihood weight of each sample. That means you have to find W1, you have to find W2, W3, and W4. This thing you have to find. What else? And after finding all these W1, W2, W3, W4, you have to estimate this probability. So now you can understand, or now you will be able to relate why these likelihood weights are useful for us. Because using these weights, we are going to estimate the probability that we are interested in finding out. Okay, so let's see how to proceed with this. Proceed with the solution of this question. Do you have any doubt in the question itself? Anyone? Chandana, Anupam, Gurudeep, Manjunath, Abhas. Any doubt in the question? Question is clear now? Shall we proceed to solve this now? Okay, nice. So first of all, what should be the first step you have to do, or you should do? This graph is given to you. So the first thing you should do is writing the joint probability distribution, because you know that you are going to use this, right? So write the joint probability distribution. You know how to write the joint probability distribution for Bayesian network given to you. So it is going to be what? Probability of A multiply probability of B given A, and then you have probability of C given B, Similarly, probability of D given B. Correct? Yes or no? This should be the first step that you have to do in order to avoid any mistake. I'm saying you can do directly also, but it's better to just take few more seconds, because silly mistake can cost you a lot in the gate exam, right? So it's better to go with the detailed approach. Sometimes it is good. Okay, so this is the joint distribution. Fine. Now let's consider the sample one, first sample. What it is? Not of A, okay, not for all, right? So this is the first sample given to you. Not of A, not of B, not of C, not of D. This is the first sample given to you. Now we are interested in finding out W1. Very simple. So not of A, that means you can just write, you can represent like this: probability of not of A multiply probability of not of B given not of A multiply probability of not of C given not of B multiply probability of not of D given not of B. Yes or no, everyone? Is this clear so far? Do you have any doubt here? Crystal clear so far? Can anybody tell me what are the evidences here? Just see the question. What are the evidence? What evidence you have to consider? Yes, everyone? What do you think? What are the evidences that you should consider? Not of A given not of B, not of C. Okay, you are talking about in this term. See, can I say that this value, probability of not of B given not of A, what can you say about this one? Can I say this will be equal to 1? Yes or no? Because ultimately, see, when I say this thing, understand carefully, understand this thing. When I'm talking about this thing, this is what? This is, can I say it is talking about probability of evidence given parent or query, you can say? Yes or no? Evidence given parent. Whenever we are writing the probability, so we have to always consider parent, probability of evidence given parent. Correct? Yes or no? Okay. So here it is not of A and not of C. So here, probability of not of A. See, this is evidence, or you can say part of evidence. Yes or no? Because not of A and not of C is given to you. Let me just write it also for you, just to make things clear. Not of A, not of C. This is what? This is evidence. Carefully understand this, okay? Because you may commit silly mistake here. Okay. So this is your evidence. Not of A, not of C is your evidence. So not of A is present here. Part of evidence present here. Definitely you have to consider this cannot be 1. Whatever is the value, probability of not of A, that is 4 by 5. So can I say it is going to be 4 by 5? Step by step. Let's go step by step. Okay. What about this? Probability of not of B given not of A. You always have to focus on this portion, because you are talking about what? In terms of probability of evidence given parent. Is this your evidence not of B? Is this your evidence not of B? No, it is not your evidence. It is not your evidence. So this will become 1. Understood? What about this one? Probability of, so we can write here 1 multiply probability of not of C or not of B. We are focusing on this part, right? Evidence part. Not of C, yes, it is part of evidence. So this cannot be 1, right? What is the value here? Not of C and not of B. Not of C and not of B. It is 3 by 5. It is 3 by 5. multiply. Probability of not of D given not of B. We should write it in small. So it should be probability of not of D, not of D. Okay. Yes. So carefully observe, not of D. Is this in your evidence? No, it is not in my evidence, right? So it has to be 1. Anybody having any doubt in this? So it should be 12 by 25. And what is this value? 12 by 25? It should be 25 into 104, 48, right? So 0.48. Is this clear so far? If you are having any doubt, please ask. No. Manjunath, we are talking about what? See, I told you here, right? In likelihood weighting, what we are actually doing? We are talking about this. The evidence is here now. This is how we find out the likelihood weighting, right? Weight by probability of evidence given parent. This is our solution, right? Is this clear? Okay. So here I should not write like this. I mean, this is not exactly representing this, just to avoid any confusion. This is what we have to estimate, right? But in order to estimate this, in order to see by this one, you will understand that not of A and not of C is evidence. But ultimately, what you have to consider in order to find the likelihood weight, you have to consider this value. I hope now it is crystal clear. Or should I write it also as a note? That would be much better. Let me write it as a note. In order to calculate likelihood weighting or weight, simply we consider probability of evidence given parent, right? So for example, in this in our question also, we want to estimate what? We want to estimate probability of B given not of A, not of C. Okay. So this is our evidence, because this is what we want to estimate. But when we are calculating likelihood weight, this not of A, not of C, this is our evidence, right? This is what we have to consider, right? So ultimately, when we are writing the joint distribution, we are basically in question, they are asking this one, but we are using this probability of evidence given parent. So we should be crystal clear what is our evidence. So whatever they are asking, this is our evidence. And now we are using this evidence in this one. So if you carefully observe here, you have evidence here. Yes, you have evidence here. You have evidence in not of B. That is not there, right? Because not of A and not of C are evidence, right? So this is your evidence, but this is not of D is not your evidence. I hope now it is clear how we are doing it. Everyone? Crystal clear? Shall we proceed now? Okay. So this is the weight for first sample. The same thing we have to do for every 4 samples. And then we have to find this, then we have to estimate this thing. Okay. So let's do it quickly. So it's B here and not of C, not of A, not of D. Okay, let me add one slide here. So sample 2 is what? Sample 2 is not of A, B, not of C, not of D. Fine. The same thing, the joint distribution will be exactly same. So we can write here, this is going to be W2, probability of not of A, multiply probability of B given not of A, multiply probability of not of C given not of A, and probability of not of D given B. because it is B, not of B. It is only B, right? It is only B. Yes, third term, any mistake? Okay, yeah, my bad. It should be B, right? Not of B, so it's just B. Yes, it's just B. Fine now. Let me just confirm. Yes, 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 yes. Okay, fine now. So what is probability of not of A? Just now we have written it is nothing but 4 by 5. This has to be 1. What about this? This is our part of evidence, not of C given B. Let's see here. Not of C given B. It is 2 by 5, right? Not of C given B, it is 2 by 5. And this is, we know that is 1. So it is going to be 8 by 25. And this value is what? It's 0.32, right? 0.32, because 25 into 4, so 100. So yeah, 8 into 4, 32. So 0.32. So let's do it quickly for S3 also. I want to solve this question entirely so that you get entire clarity. Okay, let's, so it is, this time D is not there. Rest all are not. Not of A, not of B, not of C, and D. Correct. So let's quickly do it here. Probability of not of A, B given A, so it should be not of B given not of A, C given B, so it should be not of C given not of B, D given B, so it should be D given not of B. Correct. Not of A, that is 4 by 5. You already know this. This is 1. This is 1. What about not of C, not of B? Not of C, not of B. That is 3 by 5, right? Again, 3 by 5. So it is again coming out as 0.48. Okay. And what about S4, the last sample? B and D in true form, rest all are in false form. So not of A, B, not of C, D. Correct. So let's do it quickly. Probability of not of A multiply. It is B given A, so it should be B given not of A. Probability of C given B, so it should be not of C given B. Probability of D given B, so it should be D given B. Is this clear? So this is, we know this is 4 by 5, this is 1, this is 1. What about not of C and B? That is 2 by 5 only. So which is 8 by 25, and that is nothing but 0.32. Is this clear so far? Do you have any doubt, anyone? So we have found the likelihood weight for all the samples. For each sample we have done it, right? Estimate the likelihood weight for each sample. But now we have to estimate this thing. So let's do it. Probability of B given not of A, not of C. Now estimate what? Probability of B given not of A, not of C. How we are going to do it? Yes, when not of A, not of C are given, do A and C also consider? No, only these will be the evidences, right? Manjunath, only these will be the evidences, not of A and not of C, specific values. Is it clear? You have asked a very good question. Let me just make it more clear to you or to everyone. Carefully understand this. Manjunath asked that it is given that not of A and not of C are the evidences. But now in the samples, if not of A, not of C are not there, then just let me ask you to everyone, are you going to consider those samples? Are you going to consider those samples? No, you are not going to consider those samples. Exactly, that is correct. A, C won't come in those samples. Is this clear? Fine. So a good. Is this clear now? Not of C. If you see any samples, 4 samples are given to you. If you see all the samples, it is in all the samples, it is not of A and not of C. Yes or no? Correct. But if in the exam they give you more samples, and in those samples it is not A not seen, in a single sample, it is not A not, I mean, in true form. Understand thing, understand not to consider that sample. There's a lag from my side. Everyone facing a lag here? Just confirm once. Okay, just let me know when it is fine. I'm waiting for it. I will repeat. Is it fine now? Okay. So I was saying this, that if the evidence is not of A and not of C in this example, and if they give you more such samples where A and C are in true form, or you can say both A and C are not in the false form, right? In that case, you are not going to consider those samples to find out the estimate. I hope now it is clear. Fine. Understood? Okay. Fine. We are interested in now. Finally, we need to find this. We need to estimate this probability of B given not of A and not of C. So you can simply write like this also: probability of B given not of A, not of C, divided by probability of not of A, not of C. But ultimately, how you are going to calculate using sampling, because we have the samples, right? And we have the weights, likelihood weights for each sample. So what you are going to do? Add all the samples containing these evidences. So add all the sample weights basically containing these evidences. So this in all the 4 samples you have these evidences, right? So can I say we can add W1 plus W2 plus W3 plus W4? Yes or no? And what would be in the numerator? In the numerator, it should be B, not A, not C. So can you tell me which sample you are going to consider just by seeing the question? In the numerator, which sample weights should be there? Carefully see and let me know. One and 3. Are you sure? It is B given not of A, not of C. Manjunath. What we are estimating? Finally, focus on what we are estimating. Probability of B given not of A, not of C. So can I say it should be S2 and S4, or you can say that in terms of weights, it should be W2 plus W4 in the numerator? That's how you are going to estimate it. Yes or no? Everyone, is this point clear to all of you? What I'm saying here is, carefully see, it is B here, it is B here. In these 2 samples, it is B. In other samples, S1 and S3, it is not of B. So we are not going to consider that. So ultimately, carefully observe here, it is B here, right? So it should be W2 plus W4. Correct? It should be W2 plus W4. What is W2, W4? So let's substitute the values here. W2 is, this is W2, this is W3, and this is W4. W2 is 0.32. Okay, both are having value 0.32. So 0.32 plus 0.32 divided by, what do you have? You have 0.48 plus 0.32 plus 0.48 plus 0.32. So this is nothing but 0.64 divided by, what is the denominator? 0.64 plus 0.96. 1.6, right? 1.6. So what will be this value, everyone? It should be 4 only, right? Yeah, I mean 0.4. Yeah, 0.4. Is this clear? Any doubt, anyone? This is the final value. So you can write like this: probability of B given not of A, not of C. So we have estimated this value. We are saying estimated. That means the approximate value we are finding out using this sampling. Is this clear? To find the answers for same expression, yeah, then you have to do factors the way we have done it before. There you will be using all those operations that we can perform, multiply, and we have other operations like what, sum also, right? Sum out. Yeah, factor tables will be given. You don't have to worry. Factor tables will be given in that case. Clear? Fine. Okay, so what is the correct answer here? S1 is 0.48, S2 is 0.32, 0.48, 0.32, and this is 0.4. So option A is the correct answer for this question. So you understood what type of question you can expect from this topic, likelihood weighting, everyone. This is it for today's class, for today's lecture. So what I'm trying to do is, for every topic, I'm trying to solve at least one question so that you can tackle the question in the GATE exam. Correct? And I hope, so before that, we are understanding the concept in a lot of detail. And I hope you are also, you can also feel it. What if asked to find probability of B given not of, that's what we have calculated na? यही तो निकाला अभी. अरे तो यही तो किया है. Of B given not of A, not of C. Capital B you are saying. So in that case, you have to consider both the values, not of B, not of A. You have to add them. As well as that. Or you can say 1 minus this value B, that value 0.6. Basic question, right, Manjunath? Because right, not of A, not of C is same, right? Evidence is same. Given, this is the basic thing we have already talked about a lot of times. If the evidence is fixed, yeah, basically you are kind of normalizing it, right? So normalizing means what? The total will be 1 only. You are estimating, you are finding the approximate probability, but overall you are normalizing it. So once you normalize it, the sum will be 1 always. Because it is simple, right? Not of A, not of C. Given something that is fixed, now probability of B and probability of not of B. If you add both of them, it should be 1, right? This thing we have already talked a lot of times, right? So option A is correct answer here. Now what I was saying is, yeah, so there will be just one more lecture for this particular uncertainty topic. Then this is over from my side. I have completed each and everything.